All right. Question number 5 is a stoichiometry problem. And so I'm going to take you through this one slowly here. Switched into a new video so we have lots of time. All right, first thing that we do is we're going to just write and balance the equation. That was something we were doing before we went on break. Notice one of the things that I'm doing, and I see you're doing right, is we're going to leave lots of room around this. So we're going to start out by writing our reactants, which are sodium and sulfur. Notice I'm leaving lots of room around that plus sign, writing it big, writing the arrow. Then I'm going to write the product, and in this case, the synthesis reaction, I just put the two together. So sodium's furthest to the left, so I'm going to write it first, and then the sulfur. All right. Then I'm going to, step 3, check for diatomics. Well, neither sodium nor sulfur are diatomic, so no need for any little 2's. Step number 4, balance the molecules, and in this case, sodium is +1, sulfur is -2, so we switch the numbers, and there would be a 1 there, but remember we don't write 1's, so Na2S, and I didn't leave quite enough space there, Na2S. All right, then the last thing that we're going to do is balance the whole equation. We have 2 sodiums on the right, so we need 2 on the left. We have 1 sulfur on the right and 1 on the left, so those are 1's, and we have a balanced equation. All right, the next step in stoichiometry, remember, is to just draw some lines. So I'm going to draw 2 lines, always draw 2 lines. I'm keeping them underneath my numbers, okay, and 1 line above. The ones above, those are moles, so they match our recipe, because our recipe, those 211, those are mole numbers, not grams. Down here we're going to write grams, because that's what we measure in our laboratory. This is what we are given, and these down here, this is atomic mass. All right. So once we've drawn all those lines, the next step for us is to actually write down what we're given. In this case, we're given 20 grams of sodium and 75 grams of sulfur. If you wonder where do those numbers come from, I make them up. I give them to you. It's just like if we were in the lab and I gave you a little beaker and said, here's 20 grams of sodium, go play, have fun. Okay, that's where those come from. All right, the next thing to do is to go to the periodic table and add up what we have for sodium and sulfur. Well, we already did that, and we know that the atomic mass of sodium was 23. The atomic mass of sulfur was 32. Now for Na2S, remember in problem number 1, we already went back and added that up. So we had 23 times 2 for 46, and 32 times 1, so we get 78. Notice in this one, I did not just add 23 plus 32. I actually went back and calculated Na2S. Also notice in this sodium number right here, I did not multiply that by 2, okay? We don't want to use those mole numbers at this point. All right, next thing is do a little division. Notice that these are already set up for us, so I can just do my division right there. 20 divided by 23, and if you do that on your calculator, you're going to get a big decimal number, 8696. Notice I'm keeping 4 numbers there, and I do that, I don't just round to like 0.8, because then I'm rounding off too early and I'm not going to get an accurate number. The next one, 75 divided by 32, and if I hold 4 numbers on that one, I get 2.344. Okay, not necessarily 4 decimals, just 4 digits. All right. The next step, limiting, figure out which one we're going to run out of first. And so I'm going to do a little bit more division, and I'm going to do that division, 0.8696 divided by 2, and this one, 2.344 divided by 1, and what I want to know is which one of those is smaller. And yeah, you're right, it's this one, 0.8696. So I'm just going to put a check mark on it so I remember that. And then I'm going to use it. I'm going to bring it right over here, 0.8696 over 2. Notice I'm not down in that 20 and 23. I'm staying up high using the mole numbers. Equals. This is x right here. So I'm going to do this one next, x divided by 1. Okay? I do some cross multiply and divide here. So that's going to be 2x equals that. And when you do that little calculation, you're going to get 0.4, let's see, 43, how about 48? 4348 there. And my last step is all I have to do is multiply 0.4348 times the atomic mass of 78 and put that number in there, and I'm going to get, and I'm going to round it off to a nice whole number, I get 34 grams. Okay? I get 34 grams. So that means I used all of the sodium, all 20 grams of it, and I used 14 grams of the sulfur. So I had 61 grams of sulfur left over. You have to maybe think about those last couple comments, but hopefully that took you through a stoichiometry problem, gave you a little bit more time to look at it, and we're going to do another one slow through here right after the starter.